Right, move the mic, yes. If it falls down, it's not my fault. Literally my fault. Because of where I put it, but not my fault because it's a stupid stand. Right, the camera's right in front of me, so I'm going to have a hard time. Ignore this, it's just solder and shit. Right, so I'm making a openFIRE or GUN4IR setup, and I've already made the guns. I'll probably upload something to do with that because I'm using a Wii sensor, not the recommended DF robot camera, because the DF robot cameras are like 60-70 quid, and at that point it's just ridiculous. But the Wii remote sensors, the PixArt sensors in the Wii remotes, they can also pick up 4 separate IR points, which is why they use the DF robot cam, because that can. Things like the aim track guns, they can't. So you can't just take your sensor out of your aim track gun if you were planning to do that. I might just add a diagram explaining how to make the camera adapter, but for now it's just these little IR bars. So I'm going to need to make 4 of them, and what I do is I get these, and this is how I make the cameras as well. Get these little PCBs, and they're just a bunch of through holes. None of them are connected to each other. So if you can see, they're just through holes, and they're connected on either side. These pads on the end aren't connected to each other, but all the holes are just through holes, so they're connected on this side and that side, but none of the holes are connected to each other on the same side. So treat them like a little, I don't know, test breadboard really. I prefer them to just printing out circuit boards, at least for prototyping. Right, so I've got some 940 nanometer IR LEDs here. These have got a forward voltage of 1.2 volts, so that's the voltage drop per LED. So I'm going to be running them in series, and because I'm running them in series, that's 1.2, that's 1.2, and that's 1.2, so you add them up and that's 3.6 voltage drop. So you take the 3.6 voltage drop off your 5 volt input, which leaves you 1.4 volts, and then you divide that by your resistor, which in my case is going to be 27 ohms, and that gives you an answer like 0.052 or 1, whatever, and that equates to about 50 milliamps. It's really more like 52 using this, but these can run at 100 milliamps, so targeting 52 is fine. And then the way you tell which side's positive on an LED is the positive light's always longer, but you might have trimmed them off or something. So the real way to check if they're clear like this is if you look, there's like a big flat annually bit, and then this isn't fucking focusing very well, is it? There's like a big fat annually bit and like a little small pokey bit, and the little small pokey bit is the positive. So we're going to put them positive to the same side. All of them are going positive same side. So turn my shitty soldering iron on wherever I put it. There it is. I did get my big soldering iron out, but there's no need to use that. Just this cheap little eBay special will do. Now let that heat up. Now there's two ways you could set these up, and one of them is so there, side by side like this, like that, all in a row, and that's how most people do it, but I don't like that. So it's slightly harder for the sensors to distinguish at that point. It makes one really bright spot, which is fine, but it's not really great for the sensors. So if you look at the boards I've made, you'll see that there's basically it's 6 by 6. How the fucking hell is this backwards? I don't. And there's a delay between what happens on the camera and what I see on the screen. Right, so it's 6 by 6. So the first LED, I'm going to skip a row down, so they're not going to go in the first two holes. The top two holes. It's going to come one row down, and it's going to sit in there. Right, that's my first one. So I'm going to double check which side the positive's on, and I'll put it on the left hand side, and I'm just going to bend the positive leg down a bit, and then solder. Where the hell have I put my solder? Oh, here it is. Then solder that just a little tack to the board. Doesn't need to be good. And the way you solder is you heat up the leg, you heat up the pad, and then you add the solder to the things you've just heated up. You don't add the solder to the iron. You heat the things up, and then you add the solder to the things you've heated up, and you should end up with something looks a bit like that. Right, so now I'm going to go back, check on it, make sure it's reasonably straight, which needs to come down a bit. And that's why you only do one leg. You just square it up, and that's fine. Now the second light is going to come down here. Like that. So right in the middle, missing the, so it's not going in this row, it's going in this row. So if you see that, and it's going right in the middle. And again, we're going to just twist this positive leg up towards the negative leg of the other one that we've already put there. And this camera could do with some autofocus, and then we're going to push that negative leg down. Get the soldering iron out and just basically tack these two legs together. We don't want to twist them together or anything stupid like that, because if you twist them together, you're never going to get them off again if you do something wrong. And it's bad enough we've folded them, but you can unfold them. Right, so just tack them. Again, what I did was heat up both the legs, and then what is this mic control? And I just added a tiny bit of solder so those two legs are stuck. And again, we're gonna say, oh well, that's not straight, is it? Not gonna straighten that. But because we've only done one leg, we can straighten it out and make sure it's straight and in position, which is about right. And then we can tack this leg in place, the one that's not stuck to the other leg, so the free standing leg. And we'll do that again. But by now you need 3 hands, but you get used to it. And it only needs to be lightly stuck. So, I mean, that's not a very good solder joint, but it doesn't need to be. Why is it? Right, it just moves slower. It just needs to be tacked on. So that's tacked on. We'll check that it's still straight, still level. Pretty good. Right. And now the third one, surprisingly, comes up here, and we make sure that we got them all facing the right way. So that goes to these 2 holes here. So we make like a V. Right. And again, this time we bend the negative leg down. We'll tack that leg in place. This gets a better solder joint than the one in the middle, because this one sits there. We'll make sure it's straight. It's not, but because we've only done one leg, we can easily nudge it about. Straighten them all out now. Get them kind of level. So like that. I mean, they don't have to be perfect, but they need to be pretty close. Right. Now then, these 2 still standing legs, these get folded down towards each other as well. So we can solder those together. And again, we do the same as we just did with the other legs, and just heat up both legs, add a bit of solder, and those 2 legs are set. And we haven't really soldered these legs through the holes, because that'll give us just enough wiggle room to make sure it's absolutely right. The way this is set up, by the way, is going to sit like that against the bezel of the telly. So if you don't want that kind of design, then don't watch this video. A bit late telling you that. Right. Now I'm happy with the positioning of them. I'll come back and I will. First, I'll trim off. I've broken my side cutters again. Just chopping plastic with them, so I'll just use toning clippers. I bent this leg up. It's soldered here. Right, let me just show you properly. See, I bent it up from where it's soldered, so I can snip the excess off. So that excess comes off. Do the same to this leg. Snip the excess off. Do it. And this is only happening to the 4 middle legs, basically. Snip that excess off and this excess off. And now I've been left with this now. So I've got the positive leg, the middle legs touching, the middle leg touching, and then a negative leg. And it looks like that. And currently the only things soldered in the holes properly are the positive and the negative leg. Because that tack I put in, that came loose first thing I soldered those together, which is fine, because we did that on purpose so we can just always readjust these before we finally decide that yes, those are close enough and close enough is good enough. So now they can sit on the faces pretty easily now because they're lined up. Now you just go around and solder up these little holes. And then check again, make sure they haven't moved, and solder up the last 2 holes. And clean your iron, because if you don't clean your iron, nothing's going to flow properly. Right, so now we've ended up with, where's my thing? I wonder if the lights will help. No, the light definitely doesn't help. Right, so all 4 legs are soldered to the board, and the 2 middle legs are crossing over and soldered together. Now if you want, this isn't needed, you can just heat up those soldered legs until the solder melts and push them more flat. So now that doesn't stick up as much as this, and I'll do the same on this side. So now those are pretty flat, and then I'll just add more. This isn't needed, I'm just doing it because I can. I'll just add more solder to those crossed over legs. So I've ended up with this. You see some of them I've soldered to the board, but that's fine because like I said, these holes aren't connected to anything. It's just soldered to a hole there. Right, now we double check which one the positive is. This isn't strictly necessary, but it's this one. And I'm bending this leg back up, and this is where my resistor is going to go. My resistor is going to go through this hole here, and it will eventually solder to this leg. So I'll just bend it in place. Some people like to have it bending off the side of the board. I don't see much of a need for that. It depends how you're mounting it though. And then I like to reuse these little tabs, but these little pads, but there's no need for it. So I quite aggressively bend these legs, which you really shouldn't do with resistors, but I have. And then I've ended up with basically that shape, which means I can solder that leg to this pad easily. So that's the first thing I'm going to do. I'm going to solder that leg to this pad, because that's going to be the most awkward bit. I'm going to have to hold it with my thumb, and then my thumb's going to get really fucking hot. And I'm going to pull out my solder like this and get it to about where I'm thinking of working. And I'll actually tin up this first, because you can see how I've brought the solder there. I can heat up this pad now and then add the solder like that, so I didn't need 3 hands. Then I'll do the same thing with the resistor there, which is really awkward, but try not to hold the resistor, because the resistors are designed to dissipate electricity like heat, and that means they'll dissipate heat as fucking heat too. Don't be afraid to bend the legs properly, but don't do it too close to the actual resistor, and clean your fucking iron. So now that's soldered down there to that pad. Make sure the resistor's sitting as we want it, which is fine. And then, because these pads aren't connected to each other, I also bend this leg over like that, so I can now solder it onto that pad as well, which is a lot easier because I don't have to hold 6 things. Oh. And then clean your fucking iron, because I haven't been cleaning my iron, so it got a bit oxidized and I didn't want to flow solder. Right, so that's that soldered on to both pads. Excess comes off, chip chop, bang. And now this, the leg of the resistor crosses the leg of the LED, and the leg of the LED comes down to there. And I'll trim off the excess of the LED now, so it doesn't get confusing that it's running down close to there. So something like that. And again, solder the legs to each other. Check that that's actually soldered by wiggling the resistor leg about, and it's solid, so now we can chop off the excess resistor leg. And then you might notice you got these sharp bits sticking up from when you've trimmed off excesses. Just squish them down with something, because you don't want them poking up everywhere. So I'll just use the back of my microscope here, or whatever you call it. What would you call it? Magnifying glass. Just push them down a bit, so because you don't want any sharp stabby uppy bits. Now we've got this, which is our negative leg. Unfortunately, it does not reach properly to that pad. It does reach that pad, but not fully. So what I like to do here is I just like to solder it down to some of these holes along the way. So I'll add solder here, and then I've soldered it down there, and then I'll solder it at the top here where the pad is, and that. And I'll just intermittently decide which one of these other holes also gets to solder down to. And the reason I'm soldering down to the holes is so later, when we decide to add the power to it, just heating up one point isn't going to turn into a spring and just launch it. It'll be held down. These are more structural than electrical. So, right, where's that? So now it's being held down. You can see the one at the end isn't really holding it down, but we can always add more solder to that. And those are just mechanical solder points, really. They're not electrical, they're just for mechanical. And you can see my camera keeps fucking freezing. That there, coming through there. Alright. I'm not too fussed about adding another pad here, because I'm going to be soldering the wires onto the back anyway. So I'm not going to add that. Right, let's see. Let's get some this. Alright, so what I've got is it's basically speaker wire, and I've ran it to a board like this. So I've got 5 volts from USB coming in here, and then I'm running 5 volts split into 4 ways. So I mean, I'm not going to bother showing that, but it's basically 4 5-volt wires coming from one 5-volt supply. And so I'll show it. I can show you this. This is the little octopus of doom I made, and that's the 5 volts USB going in, and then I got these speaker wires coming out. And that's just PCB soldered together and then hot glued to make it manageable. Most of you probably have 3D printers. I know I don't, but it seems like everybody I know online does these days. Yeah, and now I'm tinning up these wires, which is again, like soldering anything else, you heat up the thing you want the solder to go stuck to, and then you rub the solder against it. Wires are some of the only things you can get away with not heating up first. Well, copper wires anyway, because they absorb so much heat. You can get away with melting the solder onto your iron and then doing it, but why get into that habit? So trim those down. Right, I've forgotten which side is positive and negative, so I'm pretty sure the green one is positive and the black stripy green one is the negative. But why solder twice when you've got a multimeter? So this is just a cheap multimeter. Slap it onto 20 volts DC, which is that fucking thing, 20. That's the DC signal. That's AC, the wavy one. That says wavy, so that's AC. And this is flat lines, so this is DC and 20 volts. Because 20 volts is greater than 5. And that's all we care about. Right, so I'm assuming that this one is plus, so I'm going to use my red probe on this. Minus on that. Just squash that down, and then do you know what helps? If I plug the fucking thing into the USB, that helps. Right. So guessing that and that. Hey, you little bastard. And it is, because that's 4.92, that's close enough. So this is positive and this stripy one's negative. I've just noticed I think there might be a massive delay between what I say and what you see, so I might have to edit that in post. Right, so we double check again, just in case, which side is a positive and which side is a negative, and again we can verify that the ones on the left with the resistor are the positive. So we just remember that, don't remember left and right, because you're going to flip it over. So just remember the one with the resistor is the positive, unless it's not, because if you messed up and put the resistor on the negative, that's fine, it's not going to ruin the circuit, but you're going to forget which one your positive and negative should be. So positive, they both look green and stripy now. Right. Positive goes to the positive, this is awkward as hell, camera ain't helping. I'll get some of my solder wick to hold it in place. Might let the camera see a bit better. Right, so positive. William, okay, stop. It keeps moving whilst I'm trying to melt the solder. Right, there we go. Right, give it a tug, because the thing is with soldering, people say, ooh, it's difficult. It's not difficult, but if your solder work can't survive a gentle tug, then you've not done it right. So trim that off if we can. I could with my side cutters, but I've broken. And trim off the excess. should look something like that. And then we do the same for the negative side. And this is why I added the structural parts. I'm hitting a fan down there. That's, if you can hear a crunchy noise, that's just wires going into a fan. But this is why I added the structural solder, is because as I heat this up now, that solder on the pad's going to melt, and it might turn that leg into a spring and it'll spring up. But it didn't, because of the structural solder. Right. Now then, give it a bit of a tug and make sure it's fine, which it is. Check your work. It's fine. Don't worry about the black stuff, that's hot glue. It's everywhere. Right, so it looks like that. We'll check the lights are fine, which they are. Now, problem with that, make sure you get rid of all your little metal bits and solder bits off your work area as well, because if you don't, you're probably going to short out things when you come to test them. You don't want to do that. Right. So IR LEDs, you can't see them, but what can see them are telephones, but probably not iPhones, and cheap shitty webcams. So we'll put this down here, hold it in place, and we'll plug the USB back in, because obviously I unplugged it before I started soldering, because it would be stupid not to. Just need to find the end of it. Here it is. I'll plug it in. Let's see if it works. Does it work? It does. And you can see, I mean, it's 3 separate lights, but if you're punching straight at it, it's one big bright circle to the camera, and that's a lot easier for the IR cameras to spot compared to just a line of them, which would be more like that. So it's that versus that, and it's just easier for them to see. It's not a massive difference, but it is a difference. Anyway, that's that. That should never have taken 38 minutes, but it did because of this camera being in my face. You can probably solder them together yourself, like 4 or 5 minutes each at the most, I'd imagine, even if you're new to it. Right, cheerio.